combination of weak acid and strong base. Hello everyone, welcome back to PLUTUS STEM. So today we are going to discuss another name reaction, that is Kolbe electrolysis. We have covered up various name reaction of class 11, class 12 for JEE and NEET preparation. So this time we are going to discuss a very important for preparation of hydrocarbon, specifically the alkane moiety. So in this we know that we are going to use the sodium salt of carboxylic acid. The sodium salt of carboxylic acid in aqueous solution when it is being allowed at the electrolysis. So what we are going to see? We are going to see the preparation of hydrocarbon or alkane. So basic reaction for this is going to be RCOONA, let's say. This is the sodium salt of carboxylic acid in aqueous solution, or you can say water. The electrolysis, Kolbe electrolysis, I am mentioning on the basis of this name reaction Ke. The Kolbe electrolysis, we are passing some electricity through anode and cathode, the battery. I will show you that also. And what we are going to see over here, the product which we are going to get over here will be RR, the preparation of alkane. The preparation of alkane, which means we are going to use over here 2RCOONA, because 2R we are going to get in the product, and after that we will get in this carbon dioxide plus 2 carbon dioxide we are going to get over here, and plus we are going to get the hydrogen gases. So both of them are gases, carbon dioxide gas and hydrogen gas. This is the process, and these salt Na and OH negative, these Na positive and OH negative, these are the salt which are going to remain in the solution. So basically, if you see a schematic diagram of this, so generally we take a battery like this. Let's say this is our electrode. So this part is like, you can say negative part, or you can say negative part or cathode, and this one is positive part, or you can say this is our anode. Through this we are going to pass some electricity, and this anode, some positive moiety are going to attach, and at this negative cathode, at this minus cathode we are going to see some positive moiety, and this anode we are going to see some negative groups. So basically we are having in this solution, we are having an electrolyte as RCOO negative and Na positive. So after this passing of electricity, what is going to happen? So they are going to break up, some reaction are going to take place, and how this whole reaction follows, which is going to come at this anode and which moiety is going to come at this cathode, which gas is liberated at anode, which gas is going to liberated at the cathode, that all we are going to see through the mechanism. So if we see the mechanism of this reaction, so for the mechanism, going for the mechanism of the reaction, so we need to see we are having two moieties, R, C double bond O, O negative and Na positive. So we know it is going to be break down into two moieties only. It's a strong weak base or you can say strong salt base, the strong NaOH, the acid is strong, so that's why it is going to be break down easily. If we are using RCOOH, if we are using the simply RCOOH, that is a weak acid, that is a weak acid. So breakdown of this acid is not that much good. We know the weak acid are not break down into a good quantity. So to break down in a good quantity, we have made the salt of this RCONA or weak acid. So the salt of weak acid plus strong base is going to be strong electrolyte. So this is our strong electrolyte. It is a strong electrolyte combination of weak acid and strong base moieties. So this is going to break down like R C double bond O negative plus Na positive. Another moiety which we are having over here is water, and this water will be break down into OH negative and H positive. OH negative and H positive. So from here, at cathode and anode, that moiety is going to be attached, which is having the higher power. So from this anode part, we are going to get this RCONA negative, that is going to come at anode, and H positive, that is going at the cathode. So if you see how it is going to follow up at anode, this RC double bond O negative, what will happen over here, this RCOO negative, so it is at anode, so it is going to liberate some electron, and we are going to get RCOO free radical minus electron. We are having 2 RCOO negative, so we will be having 2 R. So 2 electron will be liberated, R C double bond O free radical. This is a free radical. So this free radical which is being generated can be break down like this, and if you follow over here in the next, that would be better, R C double bond O like this. So this break down like this, and we are going to get R free radical plus CO2. How this mechanistic pathway is following? So this free radical, if you see over here, this how they are passing through this C double bond O free radical and this free radical, and they are making some bond like this, and it became C double bond O, C double bond O. That is how this CO2 is being prepared. And another part is this R free radical. This R free radical, as we know that we were having 2, so these are also 2, this one is also 2 CO2, and these 2 R free radical, they are combining with another moieties, and they are going to get us the alkane. We are going to get over here alkane. So basically it is quite similar, easier to understand that we are going to get the even number of alkane only. Through this process, we are going to get the even number of alkane. So if we see over the cathode, at cathode the reaction is very, very simpler. We are having this H positive, and in that we have seen that we have lost 2 electrons, so now it is going to gain 2 electrons. So 2H positive, so we are going to get H free radical plus 2H free radical, and these H free radical, they are going to combine with each other, H free radical plus H free radical, and we are going to get hydrogen gas. So we can very clearly see that at cathode we are having the hydrogen, and at anode we were having the preparation, or you can say liberation, of carbon dioxide, and that Na and OH, they are present in the solution. So this was a very simple reaction, and the whole mechanism is being discussed. So for these few reactions questions, we are going to discuss how it can apply to different questions. If we are having a moiety like this, C double bond O, O negative Na. For this type of moiety, I will just tell you the short trick. If you are not this Kolbe electrolysis, if you want to follow the Kolbe electrolysis, so what you need to do, you need to do nothing, just liberate this carbon dioxide from here plus CO2 and this CS3 and CS3, this bond. So as we know, we are going to take this two moieties, so two carbon dioxide and two these moiety, two carbon dioxide, so two these moiety, and this one free radical and this one free radical and make a bond. So what we are going to get over here, if you match up in a good way, this is like this: methane, ethane, propane, butane, the formation of normal butane. Just this one two carbon, and this is the whole formation through this sodium salt of this moiety, ethanoic acid, the sodium salt of ethanoic acid. And regarding, if we are going to take C double bond O, O negative Na, if we are having such type of moiety, then the same way, what is going to happen over here? First, the liberation of this carbon dioxide and these two free radical, and they are going to join like this, plus 2CO2. So initially we are having 3 carbon chain, and afterward we are going to get a 6-membered product, twice the number. So the product is 1, 2, 3, 4, 2, 4, 2, 3 dimethyl butane. So in this way we can solve enormous number of questions. It is very important from the competitive point of view. So we can very easily, I have told you the whole mechanism also. The simple thing that RCONA, the sodium salt of carboxylic acid, in the presence of electrolysis, they are going to give us the even number of alkane. Thank you.